Welcome back to the Potential Difference Research Lab. In this video today, what we're going to be looking at is Lenz's law of induction, Heins' law of induction, Newton's third law of motion, Heins' fourth law of motion, the law of conservation of energy, and the law of creation of energy. So, and then we'll be demonstrating them all on this generator prototype. So, Lenz's law, or Lenz's law of emission, states that an induced voltage will cause a current to flow in a closed circuit in such a direction that the magnetic field created will oppose the changing magnetic field. And this gives basically it gives you the impression that work, which is denoted by the term oppose, can be performed without energy. And Lenz's law is denoted in Faraday's law of induction by the minus sign in front of Faraday's law. So if we add the work energy principle to Lenz's law, and the work energy principle states that all work in any direction requires energy, because energy is the currency required to perform work. So if the kinetic energy of the system increases, positive work is being performed, and if the kinetic energy of the system is decreasing, negative work is being performed. So if we take the work energy principle and we add it to Lenz's law, we end up with an induced voltage will cause a current to flow in a closed circuit in such a direction that the electromagnetic field energy created will perform negative work, reducing the kinetic energy of the system. So the minus sign in Faraday's law is actually negative work being performed by magnetic field energy that's created. And we're going to see that in this prototype in a second. So now, and Heins' law of induction states that an induced voltage will cause a delayed current to flow in a closed circuit in such a direction that the electromagnetic field energy, which is created, will perform positive work, increasing the kinetic energy of the system. So positive work is denoted by the positive sign in front of Faraday's law of induction. So in a generator coil, negative work is performed when current flows in the windings and a magnetic field is created around the coil such that the magnetic field energy reduces the kinetic energy of the changing magnetic field, reducing its kinetic energy as it approaches, and then also reducing its kinetic energy as it departs. Now, if we delay the current in the coil in the time domain, we end up with a scenario where the magnetic field that's created around the coil isn't fully manifested until the changing magnetic field is already moving away from the coil. And what this does is it increases the kinetic energy of the departure of the coil, the magnet away from the coil, while simultaneously attracting the opposite magnetic field that's coming into position. And that's exactly what you're going to see in this prototype. So Newton's third law of motion for every action, there's an equal and opposite reaction. That is basically, can be stated now, that negative work is performed by an electric generator by the created magnetic field energy. And Heins' law of motion, for every action there is an equal and complementary reaction. So positive work, system kinetic energy increase, is going to be performed by magnetic field energy. The law of conservation of energy states that energy cannot be created, but negative work can be performed by an electric generator without energy. So this statement is false, and this statement is false, because we've already established, well, Lenz's law already establishes that electromagnetic field energy that's created performs negative work. So the law of creation of energy states that electromagnetic field energy can be created, and this energy can be used to perform either negative work or positive work, depending on the timing of the induced current. And negative work, system deceleration; positive work, system acceleration. So in this prototype, we have a conventional coil that's connected to the load, and when current flows in the circuit, we will observe kinetic energy reduction, and we will observe the prime mover will consume additional input power and deliver additional mechanical power to the generator's drive shaft. And we can observe the output across the load. When the Regenex coil is engaged, we will notice that the electromagnetic field energy that's created around the Regenex generator coil will perform positive work, increasing the kinetic energy of the system, reducing the consumption by the prime mover, and we'll also notice that the voltage and the current across the load has increased while the kinetic energy of the system has increased. And we'll be able to observe the load current sine wave for the conventional coil on the oscilloscope, and the load current sine wave for the Regenex coil, which is delayed in the time domain. So we're going to bring our system up to rotational equilibrium, no load, steady state speed, and at rotational equilibrium we know that the mechanical power in the drive shaft is 0, and that's where we'll start. So our prime mover our system is operating at 3,503 RPM. We are at rotational equilibrium, steady state speed on no load. And now I'm going to place the conventional coil on load. See the load current sine wave for the conventional coil. The magnetic field energy, the electromagnetic field energy that's created around the coil is performing negative work, and it's reduced the kinetic energy of the system. So I'll put it on to no load again so you can see exactly what happens here to the speed of the system. So when we place the conventional coil on load, the magnetic field energy that's created around the coil will perform negative work, and it will reduce the kinetic energy of the system. And this is our voltage across the load and the current through the load. And now I'm going to engage the Regenex coil, and we're going to use the magnetic field energy that's created around the Regenex coil to perform positive work, increasing the kinetic energy of the system. And we'll also notice that the voltage and current will increase. So we're using the electromagnetic field energy to increase the output of the conventional coil and the work being performed through the light bulb. And we're also using the electromagnetic field energy to increase the kinetic energy of the system. So now our output across our load has increased. Our system kinetic energy has increased. In fact, the kinetic energy of the system right now is higher than what it was at no load, at rotational equilibrium. And we can see the load current sine wave for the Regenex coil. And we can see that the load current sine wave is delayed in the time domain. So I'm going to put the system back onto no load again. So 3,503 RPM. Our system requires 138 watts to the prime mover in order to establish rotational equilibrium. 140 watts to establish zero mechanical input watts in our drive shaft. Now when we place the conventional coil on load, this number will increase because the negative work that's being performed by the conventional generator coil causes the prime mover to decelerate and to consume additional electrical input energy, which in turn delivers increased mechanical energy in the drive shaft. And if this number stays the same when we're delivering output power to the load, then the generator is operating at infinite efficiency. Because if this doesn't increase when we're delivering power to the load, then the mechanical power in the drive shaft is also not increasing. So we're at 140 watts to our prime mover. Now we're observing Lenz's law, the electromagnetic field energy created around the region X cloud. Let's reduce the kinetic energy of the system. And we're also observing Newton's third law. We're delivering power to the load, and we need additional power to be supplied to the prime mover. So this is load current sine wave for the conventional coil. So we started at 140 watts to our prime mover and 3,503 RPM. So it takes us almost 8 watts less to deliver more power to the load while increasing the kinetic energy of the system than it did to establish rotational equilibrium on no load. And our generator is operating at infinite efficiency because the mechanical power in the drive shaft has not increased because the prime mover input has not increased. In fact, it's gone down. The prime mover's mechanical power delivered to the generator in the drive shaft is actually less than what it was on no load at rotational equilibrium, which was 0 watts. So that's basically the end of this video, and the correction of Lenz's law, Newton's third law, and the law of conservation of energy as they apply in electricity and magnetism. Thanks for taking the time to watch this video. Cheers.